In today's video, I'd like to...
The video is way too dark.
Oh, you might be right. So I need to light up this place before I can continue. But how am I gonna do that?
Just use the light switch.
Ah, psh! It's way too easy to make a video about it. Also, I need the portable light source for video captures in different locations. Maybe I can build something.
Okay, let's see what's in my little do-it-yourself box here. A nice selection of electronic parts. Okay, good, I got a couple of switches left. Turning the light on and off is a very useful functionality for a lamp. So let's take one of those. Some pliable wire, a multimeter, a USB testing device, and my very cheap soldering iron. Okay, here's a bunch of resistors, some copper wire, and yes, a bag of high power white LEDs. Perfect. A bag of empty circuit boards and few unused USB cables. That looks very promising. I can certainly do something with that.
The simplest way to build a circuit for a light-emitting diode is this one. You just need a power supply, LED, and a suitable resistor. And it does not matter on what side of the diode you put the resistor on, so both of these circuits are absolutely fine. The resistor is necessary to limit the current running through the diode. It will emit light without a resistor, but only for a very brief period of time, as unlimited current just makes the diode burn out. The maximum current the diode can take depends on the exact type and can usually be found in its technical datasheet or just online for typical types of diodes. High-power white LEDs, as the ones I will be using here, it's somewhere in the range about 20 to 25 milliamps. Okay, now my Russian friend Yuri here will tell us what kind of resistors we have to use. And of course I'm joking, I don't have friends. This is just my way of remembering this formula, U equals R times I, where U is the voltage in volt, R is the resistance in ohm, and I is the current in ampere. Voltage itself is defined as the difference in electric potential between 2 points in space. So we need to figure out the voltage drop across the resistor. The voltage drop across the diode will be between 3 and 3.3 volt. So starting with a 5 volt power supply, that means about 2 volt remaining for the resistor. Therefore, to get about 20 milliamps of current, the resistor requires 100 ohm. That's great, because I do have 100 ohm resistors out of the box without the need of combining them. So I will be using that, although a bit less resistance would also be okay, as I chose the conservative values for current and voltage. And in fact, that would make the LEDs a bit brighter.
Now let's get practical. As power supply, I will be using a USB connection. Here is one of the resistors and this is one of the diodes. The diode has a longer and a shorter pin on it. While resistors are symmetrical and can be put in either way, diodes are not. It's important to put them in correctly. The long pin has to be connected to the positive side of the power supply and the short pin to the negative side, which is also referred to as ground. Ground is the point in the circuit towards which all voltage measurements are taken. Here is a good point to cut the circuit and put in a switch. This particular switch has 3 pins instead of the 2 you might expect. That's because it's a toggle switch. The central pin is always connected to one of the outer pins. So when using it as a simple on-off switch, only the pin in the middle and either one of the others are needed. As a solid base for the circuit, I like to use these empty perf boards. There is absolutely no functionality within the board itself, unlike printed circuit boards, PCBs for short, that are made to provide all the wiring of the individual circuit. This is an example of an empty PCB I've been working with a few years ago. You can clearly see the individual traces between the components. The next question is how to place all of the parts on the board. For simple circuits like this, I usually improvise, but for more complex projects or with severe space limitations, the board layout can be somewhat tricky and require a lot of thought. For this board, the plan is to evenly distribute 5 LEDs on each side like this, and to put the resistors in the center of the board. So in the end, the board will contain 10 LEDs and only have 2 connections for the power supply. Before soldering, I make sure that the LEDs are not directly touching the board, but that there is a little bit of the pins left instead. The reason for that is to make the LEDs physically adjustable, because their light emission angle is rather narrow and I'm going for a uniform light surface in the end. For the soldering process itself, I highly recommend at least one of those third hand tools to keep the board in place. If you carefully watch the sped up soldering footage, you might notice that sometimes it takes rather long for the solder to actually flow. There are 2 reasons for that. First, as mentioned, I'm working with a pretty bad soldering iron and tip. I meant to replace that a long time ago, but well, it still works. Secondly, I'm not using any flux, which would be helpful to make that easier and faster. And this is intentional on my part, even though I do have flux available. I try to minimize its usage as much as possible because most flux variants are hazardous and/or highly corrosive. Therefore, you need to be very careful when working with flux and thoroughly clean everything afterwards. Another piece of advice. As you can see in the video, I just bent down the long pins to keep the parts in place when turning the board upside down. That doesn't always work that great, as there are parts with very short pins such as certain switches, some jacks, or just repurposed parts. In this case, a bit of tape can be very helpful to fixate everything during the soldering process. Time to fast forward a bit. After the second row of LEDs is done, both of them need to be connected without risking that the connection also touches any other point of the circuit. For tasks like this, I usually use isolated copper wire. Here is a close-up of this board. Before I continue with the rest of the project, one word of advice for building LED light sources.
Generally, I do not recommend a 5-volt power supply for an LED light source with so many diodes, as there are easier and more effective ways to do this. This setup is what I would usually use for a permanent lamp. A higher voltage allows the usage of multiple LEDs in series with only one single resistor. The voltage drop of slightly above 3 volt across the LED occurs for each individual diode, which is why this setup requires at least 12 volt to begin with. Based on the same calculations as before, the resistor should have 150 ohm. But since that was very conservative and it adds up across several diodes, I would also use 100 ohms for this particular setup. The reason why I'm using a 5-volt power supply for this particular project is very simple. As I mentioned, I want to make it portable. Towards that goal, I intend to use a standard rechargeable USB power bank. The universal serial bus here provides 5 volt, and a typical power bank is more than capable of driving a significant number of LEDs at once. This particular power bank, for example, delivers up to 2.1 ampere and has 10 ampere hours of capacity, so it should in theory be capable of powering 100 LEDs for approximately 5 hours. Speaking of numbers, here's the full setup I am building. I have already shown you the part on the blue background and basically did the same thing again. Up next is the central board with a switch and the USB connection.
For the USB connection, I will use one of the USB cables I got lying around. This one actually is a USB to Lightning cable I bought in a 3-pack from a third-party manufacturer after the original one failed. Thanks for the low-quality product. So I carefully cut open the outer layers of the cable. Once that is done, I got access to the 4 thin wires inside. At this point I took a wild guess based on common wire coloring that I will need the black and the red one. This is a typical color code for DC cables. Red is usually the positive connection and black the negative one. The white and the green wire in this cable are the data lines I don't need. But when it comes to electronic circuits, it's always better to be safe than sorry. So I decided to test my theory before putting anything together. Since the wires are fairly thin, I wanted to tin them first, which just means putting solder onto the wire. And this time I actually used some flux. The solder will provide additional stability to the wire when temporarily connecting it with clamps, and it also makes it easier to solder it to the board later. And now for the best part when building something. Yay, it actually works! I made light! This test not only tells me that I did choose the correct wires, but also that all the solder joints on the board are fine, because all the LEDs do light up. So now for the permanent solution. First I apply some shrinking tube and rubber tape to the USB cable for stability. Afterwards I fixate the cable onto the empty board using 2 pieces of sturdy filament. Well, actually I just prepared that connection for now, as I wanted to put the switch onto the board first. So I added 2 pins to the connectors of the switch and placed it onto the board with a tiny piece of double-sided tape. Then I slid in the cable, took a minute to think about the board layout, and bent everything into place. After making sure that I don't screw up by attaching both wires to the switch, which would result in a short circuit, I finally soldered only the red wire to it. As I had some spare LEDs and resistors lying around, I randomly placed 3 more on this board. Here is a close-up of what I ended up with. You will see in a minute why this makes sense. Now the time has finally come to merge the 3 individual boards into a single light source. The first step is the electrical connection. A piece of flexible wire with 2 conductive lines connects each of the LED boards with a central power board. In case you already wondered why I'm doing it this way instead of just using a single big board, stay with me, that secret will be revealed very shortly. Once the last solder joints are placed, it's time for another test. As you can see, a successful one. The plan is to join the 3 boards using a lot of hot glue. But before I do that, it's time for another cleaning, especially the last solder joints. I already cleaned each of the individual boards off camera, but here is how I generally do that. With an old toothbrush and some isopropyl alcohol. This will remove residue from flux as well as fat from fingerprints and other substances that could either corrode the circuit or prevent glue from sticking to the board. My hot glue gun is one of my favorite toys for do-it-yourself projects. It can glue most materials to each other when used correctly, and the glue itself provides some volume, so it can also be used to fill cavities. But of course hot glue is not suitable for projects that, get very hot. Typical hot glue will melt at around 120 degrees Celsius, which corresponds to 248 degrees Fahrenheit, and already starts softening before that. So this is why I used 3 small boards for this project. I wanted to join all of them together, but not in the shape of a single plane. I'm going for a studio-like white light surface, and this is just the internal light source. After it is done, I will begin mounting it in a very simple but functional casing, an empty ring binder. The mechanical connection between my newly built light source and the ring binder was a bit tricky. Mainly because I wanted a solution I can easily set up whenever I need the lamp, but also disassemble it again for space-efficient storage. A permanent connection had been significantly less work. So this is what I went with. I bent a piece of filament into some sort of a clip-on mechanism. This took quite a bit of time for fine-tuning and precisely connecting it to the lamp, but now it works really well. I can easily slip the lamp onto the metal part inside the binder and it stays there reliably, even when moving the binder around or shaking it. I also thought about using clothespins or some sort of clamps, and I guess that could also work. But I didn't have anything along these lines lying around, so I decided to improvise and work with what I had available. And this is something I really like about do-it-yourself. Not always having the perfect parts for a specific purpose, but making it work nevertheless. The only thing I actually bought for this project was the bag of high-power LEDs, because I had some of those diodes left, but not enough. Now the light source is done and it's time to prepare the binder. These final steps are very simple. To maximize the light output, I coated the inside with aluminum foil using double-sided adhesive tape. If you plan on doing something like this, pay attention to the fact that aluminum foil usually has one side that is more reflective than the other. Fun fact! Aluminum foil is sometimes also called tin foil, which is outright wrong, because the metal actually is aluminum and not tin. Okay, almost done. Time for the first demonstration. As you can see, it is fairly bright and completely suitable to light up a small room or a camera setting. But if you look closely, you will notice that the light distribution is not completely uniform. And that's not really surprising. Neither the placement of the LEDs nor the aluminum foil is perfect. But there is a very simple and cheap solution for this. Thin, white crepe paper. Here you can see the difference. On the left side without crepe paper and on the right side with. In my opinion, that's a pretty nice result. And this is what my new lamp looks from the front. Let me know in the comments what you think, and whether you're interested in other videos about LED lighting. For example, on how to make LEDs dimmable and driving them with microcontrollers. This is my programmable background light behind my computer screens I built a couple of years ago, and if you're interested, I will gladly explain you how to build something like this.
If you liked the video and you want to see more content like this, please consider supporting the channel by executing this algorithm. You will find all the necessary links down below in the description. Thanks for watching and have a nice day!